Let's try this again. Good evening, everybody. Welcome back into the Dragon's Den. I hope everyone's doing well this evening. Waters, hello. Pete, Timor, welcome on in. So you'll notice something a little bit different, and that's my mic sitting up here. For whatever reason, my lav no longer wants to worky, probably because I coil it up at night and I've now damaged it. So I'm going to have to get a replacement or snag the one off the other one for now. I'm gonna have to try and get a replacement. So we're gonna go with the clip-on for now. But hope everyone's doing well today. So I was going through the manual, trying to get my head wrapped around things of where we left off and what we had left to do. And I realized, one, I still hadn't done our LCDs, so we'll have to do some of that this evening. But we also need to mount the carriage before we can start building everything up on the X carriage. In order to mount the X carriage, we have to run belts. So that's pretty much what we're going to have to start with, is running belts tonight. And then we can go ahead and start putting our tool head together and getting that going. Now, I did also notice when looking at the parts for the tool head that I keep looking for where's the X end stop? Where's the X end stop? We could go sensorless. I'd much rather have an X end stop than go sensorless. And the brain fart here. If we go with a physical end stop on X, there's a piece missing. Let me show you what I'm talking about here. Hey, Free Heathen, how's it going? Welcome on in. So if we start looking at the carriage assembly, which should be carriage assembly, we have the one on the left is for a 15-15 rail. The one on the right is a little more complex. It's for use on a 2020 if we were putting an ant head on, say, a typical Voron Trident or 2.4. So you would start off by installing some hex nuts. We don't need those on our metal carriage. Hey, Eagle and Dragon, how are you doing? And this is where I keep getting stymied, right? An M2 self-tapping screw and a D2F-L end stop. So here's the thing. Looking at the files, right? And I just finally started looking at it, it's like, okay, under the X-axis, there's probes, there's joints, there's a carriage. The carriage shows the typical carriage like the metal one we have with no X end stop mount. XY joints are just the XY joints, nothing useful there. Clicking on the probes, this is where we start to get somewhere. There is an accent part here if we're going to be doing sensorless homing, which I would prefer not to do sensorless homing. I prefer physical end stop switches. That's just my preference, and that's what we're going to roll with. So we have a choice. There's a beacon probe mount, a BQ micro probe mount, the bottom brace, which we don't need, or at least I'm pretty sure we don't need, clicky probe or clicky probe wired, PCB or wired. And I'm like, well, what the heck? The instructions show this beacon probe mount, and what you'll see when I zoom in here is, interestingly enough, here's where the bottom would bolt into the bottom of the carriage, and then right up here on this top right edge is where the end stop would mount. And then of course you have the drop portion for the beacon, which we don't need because we're going to be doing nozzle probing. So I think what I may do is take this, bring it into the slicer, and just do a straight cut and just do this bottom mount here that we can then screw on at the bottom with a end stop. Now, if we just look at the bottom brace, at first glance, this looks like, oh, this might be what we need and we'll just use this. But there's no provision here for the end stop. This is literally to do a brace on one of the other probes. So we can either grab something like the clicky or the other one. Same type of thing here. There's for the X end stop, which means this would screw into the back, but we're not using clicky and we don't have that brace that mounts in there. So I think what we're going to do is just take the beacon probe. I will cut it right underneath this area here, and we'll just mount this up to the bottom of our carriage. I don't necessarily need to do that right at the moment because we still will have the ability to mount this because it goes into the bottom of the carriage. So we'll be fine to mount that after the fact, so to speak. So I just want to tell you what it is I'm going to wind up doing so that we can get that done. I do have the files pulled down over on the laptop. We'll just need to add those when necessary. And you'll see that basically I'm going to cut this lower portion off here at the bottom where the screw comes in, and we'll screw this into the bottom of our mount. Hey Pez Liz, how's it going? Hope you're doing well. This is the 2020 carriage, talks about belting it. And then we're going to start assembling our hot end onto said carriage, and that's where we're going to have to go in and get our belts done first. So with that, we'll come over and look at our fusion drawing a little bit and just try and figure out, okay, what is our belt path so that we know exactly what our belt path is, and we can go ahead and get things started. So we'll just be able to kind of walk around and see how our belts are going in. So left side beefy idler is lower, and that's probably where we'll start off. The other thing I will say is, wow, that camera is wonky. Oh, we're zoomed in. There we go. Is I did reprint this part, and if I can get them kind of at the bottom, you'll see that the one on the left over here is a little bit shorter. No, come on. Focus. Yeah. So this one's a little bit shorter, and it's 2 millimeters shorter. I just cut it 2 millimeters shorter off of this end and reprinted it. I need to put the heat insets in here, and then we'll be good to go. And this will now give us our same 20 millimeter offset as, whoops, for the other side as we have right here with our knurled nut or knurled standoff. And this one will then mount up here and give us the ability to mount our board for the piezo probe. Okay, so we got some of those things over there. Let's grab our printer. Once again, pretty cute little printer. We've got our wires coming up here. I'm going to see about printing either some covers here, or it might actually get covered up when I print those side, what they call them, like crap catchers or whatever. We've got our 2 side fans coming into a 3-way. Our main blower fans coming into a 2-way JST back here. Let me see, maybe this will do that, and we will bring you guys back in here. There we go. So we've got a 3-way JST connector right here, and we've got the 2 fans coming in will come out of there, will come out of here, and these will be fan connections that will go down underneath, and we'll have a thermistor connection that will go down underneath. We do have a zip tie spot right here, as well as a zip tie spot right here, so we can keep this wire. We'll add to this one, zip tie it down, come across, pick up this wire, zip tie it down, and then bring it over, join in with the rest of our wires, and go down underneath. These wires, once again, will be cut short, and our GBB 15 board will mount underneath here, and that'll clean that up some, and then we'll start doing other gantry wiring at a later date. But for now, we'll flip this back around. I'll bring you back out, and we're going to work on some belts. And standard belting operation, we'll run one side, get a typical amount, and then we'll come back in and do the other side. So this is going to come out this way. So back side of the belt, back side of the belt. And this is the side that it goes through, around, front side of belt. Okay, so I'm just trying to walk my way through how this belt needs to go. And it'll come this way, around that, around this side here at the bottom, meaning the idler pulley. Bring this around. It's going to go straight through the back, around the lower idler pulley back here, and then on this side it needs to go around the lower pulley, around the motor, and then the other pulleys. So we're going to try and hopefully just push this in and around, and we'll have a decent amount of curvature available to us. And that answer is no, so let's see if we can't give ourselves some guidance around our motor pulley. There we go. We'll come back up along the side here. So how's everyone doing this evening? Hope everyone's having a good day. It's been a fairly fun day for me. You know, bunch of meetings, but you know, that's kind of my life. All right, then we'll come up and go around our beefy idler, which is probably going to be a pain in the butt just to get it going. See if we can oh, not that. I use to influence this to go around without having to pull my idlers out. Probably just be easier to pull the idlers out. Or at this point, just to come back around, go around this, come back to the front, and we'll just call it our excess buffer to the belt. I don't know why I always do my belts, and then, like I said, I'm going to leave some overlap. We got a little bit extra here as well, so we'll leave a little bit of overlap, maybe 6 or 8 uh, teeth. And we'll go ahead and cut that. Now we can pull this back out, and we'll do the process where we make our belts the same size. So that is, come over here. This is the remaining belt on my spool. So we're going to take our cut belt, the one that we just cut to length, and it's going to go in the right above the first tooth on this belt. So that what that does is, as we keep these teeth lined up and we work it up and through, we will we'll be able to get our belts cut to the same length, and it'll be the same exact number of teeth. So we're going to start off, when we belt, we'll belt from the same side both times, and we're going to start by just exposing. So what we're going to do is we're coming down here, and that first valley that's shown here is the one we're going to cut, and that'll make sure that both of our belts have the same number of teeth. Okay, so we now have 2 equidistant belts here that we can use, and by showing, or by, when we belt them and just having the same number of teeth exposed, that will ensure that we have the same belt tension, starting belt tension, when we run our belts. So you always, if you've got words, make sure that your words are readable. That's, I guess, how we always start off, I guess. We're going to start off at the left side this time, which means we're going to come around this toothed idler and back towards the front. And we'll see if we can get this to go around our front idler without having to take it off. We're going to go ahead and work this around itself. The last machine I did was amazing. Thank you, Free Heathen. I'm assuming you are referring to Magenta Rising, which is the rebirth of Mercury Rising, which was the 0G Mercury build. Come on. There we go. This comes down, gets fed through. Once again, this is the lower of the 2 belts. Make sure it stays down in the slot there. And there's no front edge here. Oh, What do we do? So, Miss Liz, do you have a countdown for us? Do you have the countdown for us for 3D Printopia? Okay, we've got that worked around our motor pulley, our lower pulley, the lower pulley back here. I'll bring this through. We'll run it down the side slot here, which will get us around the other lower pulley on this side, making sure that we haven't jumped out of anything. Come forward, drop down in that slot, and we'll need to come back around here at the lower edge. Work with me. There we go. Hip hip hooray, we've got a belt run. At some point, one of these days, I'm going to grab a small biter clip and leave it up here so I can just like clip the belts right here and just hold them. I guess I could. What did I do with it? There we go. We're going to just use the forceps. And our forceps, I don't want to get it too tight, but this will enable me to hold these belts together. Just like that. So I'll have a little bit of tension, which should make it easier, hopefully, fingers crossed, to run the next belt. And the next belt, we're lucky there's 0 words on this one, so it doesn't matter which side it goes. Dun, dun, dun. Dunk and run. We got a dunk and run. All right, Freeheathen. Oh, nice. Hey, K2 Kevin, how's it going? Daisy, how's it going? I am sorry. I have been remiss in looking at everybody. I'm doing good, K2. CFS on K1C update. You're on your 3rd CFS. Seems to be a quality issue on the CFSs. Auto feed issue. Crowley says just send it back and get a new one. The issue is fixable, but with new stuff. Come on. Yeah. So real fast, Timor, is this the 3rd CFS unit you've been using on your K1C? Or is this the 3rd CFS that you've tried with the K1C CFS upgrade kit? Hey, Petty, how's it going? It's belting day. We are starting to belt the carriage up here. And so we're going to start from the right-hand side, this side, since it seems to be a little bit easier to try and get stuff routed this way through the beefy idlers. So we'll get this going from around the front. We'll get ourselves some slack. We'll kind of try and work on bending this around itself some. And then we'll start running it around the beefy idler here. And I may need to use my tweezers ever so slightly. To direct the belt in the right spot. Into the back of the extrusion. So we did the lower belt first. Now we're coming back and doing the upper belt. We're going to come through the gap here. And remember, the upper belt is now this one that we're going to be working our magic around. Oof, done. This may be more fun because of that end stop. Hopefully, we can get this belt to do our bidding. And start going around the pulley. Apparently that was a wonderful idea and thought. It has other ideas. Okay, so the belt just came out here. That's nice. It did go around the pulley. But now I have to feed it back in and around itself. It would probably be easier if I move this out of the way. Loosen that up. Should hopefully be able to slide it down. Now I can get a little bit better angle here. And there we go. We are around. Now just making sure that everything is staying in its place. We'll scooch this back over. Oh, come on. For the love of Pete. There we go. That wire out of the way. Over here, we're coming through on the top. Everything aligned. And then up here, we got to go, I'll say, kind of down here at an angle to get it through. And we'll drop it down in place. And just like that, we now have two belts loosely run, and we'll be able to mount our carriage. And carriage gets mounted with, is it M3x6 or M3x8s? Let's see here. M3x8 button head screws. Awesome. You need to try a Micron build. The Micron is a fun build. Like I said before, the The only issue with a build like this is the 1515. It's smaller. It's when you get big meat mitts, it gets hard to get into everything. So that's the only real issue I have with it. Now, we're going to be going through metal into metal, which means we should be able to put a little bit of threadlock on these, which is probably not a bad idea. Don't need a whole bunch. You don't need gobs. You just need a little bit on the thread. And the way the belts go, they're going to come around from the back and through this slot right here and be fastened down across the front. And we don't need that much. I'm going to say what? One, yeah. Starts with a tooth, yes. So 1, 2, 3, 4. 5 visible valleys. And that's where I'm going to put this one. And because we're going to be count that off again. 1, 2, 3. Now, what I'm going to do is undo this off the bottom so I can get this one through here as well. Because once again, we want them to be equidistant. Make sure that those are looking about the same. Give a slight tug on these to pull the slack. Because our belts are going to be basically clamped to the carriage. That's how this is going to work. So we'll get one of our screws started. Once again, make sure that the same number of teeth are showing, and they are. Now, we're also going to have to run the other side through, and I probably should have done that before I did this because this will now no longer work. Dang it. Gonna have to pull all the belts through, and then we'll slap it together and we'll adjust it while the screws are loose. M2 screws are your enemy? Yes. I'll just go with that. Yes, they are. M2 screws really suck. That's the other issue with doing a Micron build or a salad fork build is you've got a lot of M2 screws for the mounting the main rails. So I'm trying not to pull this side through. And at the same time, I am trying to look and see what kind of slack I have over on this side. Because I should be able to kind of put some pressure on the left side and pull any slack out of the right. Trying to make sure that these are staying equal. And then also making sure that everything stayed in place, nothing is jumped. Nothing is riding up on a bearing flange. These are good. That should be good. I will go ahead and get a screw in here, which will start to lock down the left side. Do another one, and then we don't want to pull this, like, we're not trying to get final tension. That's what our beefy idlers will get us, is our final tension. We just want to make sure that we don't have a bunch of loose slack in our belts. Okay. That's going to be good right there. That gets all the main slack out of the belts. So we'll tension them using the beefy idlers. Um, crimping, yeah, crimping can be annoying, especially if you have to do like some, what is it, the pH connectors, the really, really small ones. But crimping for me is getting a little bit easier, I guess, because I've been doing it so much. But the I'm going to go ahead and cinch these down. And we'll check that we've got everything is still moving decently. Now you notice right there we just got a whole bunch of slack in that. That's okay. Once again, we're making sure that everything is still lining up. We're not tensioned yet. And you don't want to apply tension until you make sure that everything is riding nicely. And what I just did was I brought this to the back and made sure that it's hitting the back and it's staying straight. We can do the same thing by taking it forward and making sure that when it hits at the front that there's no excess slack one way or the other. And we can start tightening down our beefy idlers a little bit at a time. I'm not going to do final tightening. I'm just going to add a little bit to get rid of that loose belt slack. And the way I'm going to do that is I did 2 turns. So these two should be back into alignment. I'm going to do 2 turns over here. Now, that's not fully tensioned by any means. We'll do our standard tensioning. But you'll notice now when I go to move the carriage around that I'm not getting any buckling in that belt. Right? There's still a little bit, but not that much. But once again, we'll get to full belt tensioning in a little bit. You got a long life sentence. Uh-oh. Uh-oh. So we're going to start to mount our tool head now. So what we're going to do is go ahead and cut this on this side. So what I'll do is I'll see if I can't count out the 5 like we did on the other side and give us a little bit of nub on both sides. Okay, and we can kind of do our little fancy smancy things, and you'll notice that our little clipped edges, this is one over at the top, one over at the bottom, so that means that these are the same number of belt or number of teeth. So boom, our belts are equidistant. We've got a little bit of flap over here that we can push out of the way when we go to put our tool head on, which is kind of the next thing we're going to do. So let's go back to our instructions here for the ant head. Okay, we're going to mount the Revo, we're going to mount the hot end with M3 by 25 socket head cap screws, which I do not have out here, so let me find those. Yeah, I find that using my iris is better than doing the crimper that I have in my Go kit that does both of the wire and the insulation crimp at the same time. I think it just gives me better control over the process. Okay, so as we're mounting this, there are kind of 2 distinct channels on the back of the hot end here. So the hot end wires, I'm going to route up one channel. The other channel is going to get the thermistor and our piezo sensor. And we got to be careful that we don't fold this over. So I'm going to just do a little bit of wire corralling here and get this lined up, push it back. Wire, go in, channel. Thank you. Appreciate it. Appreciate you. Apparently should have hit this part with a reamer. Again, you just want to make sure that you're not pinching any of these wires. And if I realized I was going to be running this through the entire hot end, I would have run the screw through first. All right, are we lined up? What is, oh, because I'm high in the gap. Sweet. Pull this back out, and I guess we'll get this just to where the threads are popping out. Then I'll go ahead and get the other one started, because why not? Like I know that Evil Diesel has issues with his hands too because of the nerve damage and stuff, and he winds up, we've got the Frax, and that works out really, really well for him because it gives him a little more stability. Now, the other thing that I'm running into is the same thing I know Steve was running into, and I'll illustrate it with one of the printed mounts here. Okay, so this part goes flush up against this part. So let me get my wires kind of in the bloody channels again, and then we'll slide this on there. Okay. And I don't know if you can tell, but this front piece is getting pushed out some. And it's getting pushed out because of the heater core. So I believe what he did was he brought it down some and then folded it back up on itself to mitigate this bump out, so that basically this is folded in on itself and we've got just the bare wires coming up, which allows it to sit in the channel easier. So I'm going to move those piezo wires out of the way, and I need to manipulate the wires for this heater, and I'm actually going to take it off to do that. But yeah, Evil Diesel has found that using the Frax arm actually works pretty good at supporting his hands when he's trying to do any soldering. Okay, so what we need to kind of do is once again bend this down and then back up without fatiguing the metal strain relief there in the process. So there's sort of the down, and now I need to bring the wires right here and kind of do the go back up gently. And the other nice thing about that is it should be right underneath the this area right here where it winds up bending up. Go ahead and get this screwed back in. So thermistor that way, these wires this way. They are still higher than our nozzle. So hopefully that gives us the slack that we need to be able to get this in here without, having it pop at an angle. Still a bit of a jiggle there. I wonder if that is, there's only 2 screws that have gone into this, and they're both at the top. I don't know. We'll see where it goes. See where it goes. We'll have our wires here that can bend down right around the back here, and we'll come into our tool head board. We need to add in our fan with some M3 by 12s. We did put our heat sets in there, so it's going to be M3 by 12s. We're going to move the small fan. Awesome, and this has a micro fit on it, which we'll have to cut off and change over to a JST. And what I'm doing is just double checking it is a 24 volt, so that's good. And remember, there's 2 options here. It's either the M3 by 12 if you put in the heat sets, and if you put in the standard, it would have been a M2 screw going into plastic. And I know Steve did that, and he was fighting it because it's just so I'll say tiny and not a whole heck of a lot of meat going into this. So you got to be very, very careful that you don't torque it and rip it right through your mounts. And quite honestly, there is, I mean, this is a 10 and we're putting a M3 by 12 screw in it. So we're getting not a whole lot of thread engagement. I may look at swapping that out for a 14. We'll see. And I think there's a spot for wire to come here, and there's obviously okay, I think this is this. There's a spot for some wire to go there. We'll hold off for the time being. LED, we had that piece is already pushed in, so we have our LED diffuser already pushed in here. Already pushed that down in there. Now we need the LED assembly. Be sure to pay attention to the orientation. Things will not go in smoothly. Place the LED carrier into the main body, and the space over the LED diffuser. Insert your NeoPixel into the LED carrier. Ensure the LED is pointed down so that it will light the side with the transparent diffuser, okay? Insert wiring into the top channel of the LED. So it says to put this carrier piece in first and then insert your LED into it. Yeah, so the way this is going to go in there, on this piece, you'll see that there's this little tension clip here. Okay, so there's a clip on this side that will pop out and hold this thing in there once we slide in. So we're going to slide it in this way where the opening for the LED is at the bottom. Then we'll come in and push the LED in afterwards. So we're going to take this and slide it in this direction with the opening at the bottom side facing downward. So we're just going to take that, slide it in, and it should press fit in there just like so. And we'll be able to put our LED in and then route our wires up through that channel right there. So now we're going to have to do LED wiring because we did not do that beforehand off camera like I said I was going to. So we're going to set that down. I need the LEDs. I'm going to need some wire. Not this. This is way too heavy. Where did I put the LEDs? Actually, I probably put them back in the thing here, didn't I? On that side. There we go. LEDs. There's 3 of them. There's more than 3. We only need 3. So we'll grab those. We'll need the soldering iron, and we're going to need some really, really thin wire. We'll have power, ground, and some type of signal. So let me see what I've got. We've got orange, we've got red, and we've got blue. Do I have a decent amount of black? I do have a decent enough amount of black. Alrighty, so we have black, red, which should be plenty enough for toolhead RGB wiring. So that's pretty decent length. So black and red, and we'll need a blue or an orange or something. Let's do blue, it'll stick out a little bit easier. So the blue here will be our signal wire. Just get our same length here. And we'll wrap this back up. Yeah, our good wholesome friend Chris over at KB3D has some wire, but I'll say not a ton, as in instead of certain colors, he's got orange. It's, like no green, but you can get orange, which isn't bad. You just have to be cognizant of it. Okay, so we've got 2 right here that are going to be small jumpered, and then we'll have a longer run to here, and then we'll have our excess coming out. And the small section, oh man, that's going to be fun because it's going to be close enough that I think what they did was they just soldered pins, like literal pins from, say, like a JST connector or a DuPont connector, like a GPIO connector. So that is an option that we can do, is just use a piece of hard wire, or this would be one of those places where you could use solid strand wire if that's what you have. The big thing here is knowing which way the voltage is going, and in this case it's going to go through the top LED and then into the nozzle LEDs. So break this off, and all of our arrows need to match the arrow on our template. So however we want to do that, the arrows need to go in that same direction. So that way, and that way. So we're just going to make sure once again that all of our arrows are matching the big arrow that's printed in the part. We'll make sure that these are pushed down in there. And what we're going to do when we start soldering is we're just going to go through and solder all of the pads up, and then we'll come back and do other stuff. Hey Zombie, how's it going? Yes, we are glad that Cutie Chris started this chaos. Like, he was the first person that sponsored me. So he's the one that got me started in all this fun stuff. And how's it going, Zombie? Hope you're doing well tonight. Yeah, because all of this is still fine stranded, and I'm not going to be able to, well, maybe I might. God, that's might have to break out the brand new tweezers for this if I'm going to do what I think I'm going to try to do. And I will be sitting down for this part because we are going to be doing some soldering. I don't need the OmniFixos for this because we're doing that. We're going to start, like I said, we're going to start by just tinning all the pads, and then I'll do the long run, and then I'll make the decision off of this if I'm going to go through and do the short run here with some wire and how fiddly it's going to wind up being. So you finally got an 85X. Nice. Very nice. Yeah, the 85X is a decent little machine. I like that it mounts all of its spools right on the side, right? And I believe I've seen there is a, I don't know if it's from the FlashForge folks or if it's from a third party, but I believe there is a enclosure already out there for it, so that's cool. So once again, we're going to go through and just tin all of our pads in preparation for soldering. Doesn't take a whole lot, and you don't want to get like a huge bead on here where you wind up running everything into one another. For PLA mostly, yeah, there you go. PLA and TPU, it surprisingly enough, it did a really good job with TPU. Now, the unit that they've had down at Ecovate was shipped to them. It was a pre-release unit, and they changed the nozzle. And when I say change the nozzle, I do mean they changed the nozzle. They sent replacement nozzles, and it, like the way they mount is physically different. So they need to do some other stuff to it. I'm going to go ahead and undo that for now, because what I need to do now is I'll get my wire ready, and I'm just going to bend up my solder like this so that I can come in with the wire and the soldering iron and tend the wires themselves. So blue is going to be the signal, which will be right in the middle. Then we'll have positive at the top, then negative. And once again, you can do a solid bridge here. You can go through and say, okay, it's going to be like X amount, cut it and try and like really you're going to be working with like this much wire for the gap there, and trying to strip two ends of PTFE that small is going to suck. So that's where I might go and just grab pens and do a physical pen junction. Do I have, I mean, I do, because I know what I can do. Because I have connectors like these that are made to solder onto boards. And all you have to do is just pull the connector out with a pair of pliers, or pull the pin out with a pair of pliers, and you'll have a pin that you can use to do your solder jumper here. They had run some multicolor TPU, yes. So we've now got our pens, and if I lay one of these on here, you'll see that that's going to be pretty much the perfect length for these. This is why we want to use a pen here, probably. And I'm just going to have to, use some tweezers, get things laid in place, and hit it with some heat to try and get this done. So once again, I'm going to try and hit both sides of this with some heat to get some solder on each side. Don't need a bunch, just need a little bit. And we're just going to do this to give ourselves a little bit of an easier time when we go to solder this down. This pen does have a little bit more mass to it than a whatchamacallit. And that's what I was afraid of, is I just melted the tips here. Great. It is going to have a little bit more thermal mass than the wire would be, so having a little bit of a tin on the edge is going to help. And once again, with the size, once you get one side soldered, you just hit heat on the other side and it should join real easily without any issue. All right, one done. Now I just need to find my other pen. And I'll try and tend this a little bit differently. I'm just getting in there and looking and making sure that I did get a good connection with that. Hey, Bearded Printer, welcome in. Hey, Hutch's Makerspace, welcome in. Havoc. The 85X is a really good, solid printer. And yeah, Zombie doesn't hold back when if he's got issues, he will mention the issues. And I'll tell you this: every printer is going to have issues for somebody, right? Every single printer is unique. As much as everybody likes to say, oh, well, every bamboo is like every other bamboo. Printers have personalities because they're built by people at different times, right? Maybe you get the worker, it's the last build that day on a Friday, and they had a bad week. So you get, maybe a QC didn't go off as well as it should have, right? Okay. So I got a I think I have a decent connection. I'm just not happy that it's not straight. Now I've got it connected on both sides. So I'm not necessarily happy about that right now either. And I guess it's connected on both sides. So there we go. That's what we've got as far as our pins. And you'll see the one at the bottom is the one that I was not liking as much. But they're going to be a sturdy plate now. Now we need to go and get our wires pulled out so we can do one side at a time. And we've got 5 volt, then signal, then ground. So we'll start with our red wire. Red wire. We will pull a little bit of our sheathing off. We'll tin that and then we'll tack it on there. Come on. There we go. And we'll figure out the length. We'll cut it and strip the other end here and we'll get that one done. And then the other side goes, of course, to the opposite side. Guess I could probably zoom you guys in some so you can see at least a little modicum more of me trying to solder stuff. I need to probably get the length and do the future ones both ends separate. Nice. We'll hold off on doing those. You're most critical about the things you love most. Yep. And you plunked cash down for the U1, didn't you? Or did you go through with your U1 backing? Yeah. That's I I was sitting there, I kept like, do I? And I'm like, I haven't had a chance yet to play with the one at Ecovate, and I don't want to plunk down money if I haven't had a chance to play with it yet. Which that statement in and of itself right there just sounded wrong. But I know everybody knows what I'm talking about and the fact that, oh, wow, that was longer than it needed to be. Dang it. I mean, like I said, it looks good. I just don't know if it's right for me at this particular point. But there's a lot of new and exciting machines coming out on the market. It doesn't have to all be, you know, oh, this machine came out, let's jump on the hype because, you know, they got $7 million plus in backing. I think they're good. If they can't bring a printer that's out there in the wild right now, if they can't fix the issues and bring it fully to the market with 7 mil, then I think there's some issues. And Snapmaker is well known, so they should be good. No affiliate, no shill, nothing like that. I mean, we can talk affiliate because I now have an affiliate for our good friends at Voxel PLA and amame. Ugh. And both codes for those should be live. So if you do bang voxel or bang amame, you should be able to get to either one of those codes. Okay, so progress shot here. We've got our jumpers. We've got our 5-volt signal ground. 5-volt signal ground. And then we'll just take whatever excess link is left and do it on the last side and bring it on out. And we'll cut it to length once we get done with everything here. So same, heat the wire up, tend the end a bit, apply the heat. Red, then blue, then black. Thanks for the alert, zombie. Yeah, you'd rather get the black box working. Yes, I need to get my black box back up and running. I've got some things working around in the back of my mind, and if the stars align, then I'll have a couple of changes to announce in the semi-near future that will make life around the Dragon Den a little bit easier. All right, there's two. Now we just need the black or our ground. And we'll be able to start doing our wiring stuff. And if memory serves me, I think it talks about the logo light. I'm not sure if it talks about the tool head light and how to mount that. So we may have to freewheel that. There should be a channel that we can route the wires into. So this goes down here. Let's go over here for now. These will put back over here. Coffee. Okay, so there's our wires. Let me take a look at the instructions real fast. We'll look through these together. So it talks about the carrier, adding in the LED and bringing the wires up, mounting the grill assembly, and then assembling that over onto the main body, screwing it down, adding the fans, the extruder, yeah, it doesn't go into talking about the lights here. I do know the lights go in the carrier gets added in, and then we have to finagle some things to get them in. Let me, yeah, that's going to go in like that, which means our lights. Why does it feel like I'm lined up for? Just trying to see how this goes in. Sorry, folks. Kind of what I get for not watching all of the instructions. Dang it. Let's go back to printers for ants. The ant head. I don't think it's a user mod for the lights. Maybe it is. There's the LED solder fixture. So maybe it is. Bum, 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 bum. standard flow and head. There we go. So print each of the following pieces. We did. So it's going. Yeah, so these are going to go in. Whoop. There like that. That piece clips down in there. And then it will slide in. Okay. So with that, if I come back over here to the bench side, so we've got our LED wires and we've got our carrier. So this side is where the back side of the wires you'll see. So our LEDs need to slide down in there like this and get mounted in there. And I'm going to have to play with my wires a little bit. Get it down in there eventually though. Doesn't seem like it's fitting all the way down in there right, but I think it's partly because of the way I'm thinking how it should sit in there versus how it does sit in there. So we're kind of setting these up like that, right? And that's where I'm like, it doesn't feel like it's going all the way down in there. And it feels like the angle's off. Ooh, and you know what? It might be being caused by that one solder joint that was at a weird angle. Might actually be what's kicking it up from where it's supposed to sit. Seems fit a little bit nicer. Then we'll take. Now I'm coming out the opposite side of where it wants me to, but once again, it's that leg right there being at an angle is keeping me from getting it wedged down in there far enough. So I'm going to have to come out the opposite side of what it's telling me or showing me in the instructions. And then this piece, there's a little clip hole right here that this will fit into. Which, once again, I think that, yeah, that leg is going to get in the way. Actually, no, it doesn't. But I just did what Steve did, which was break the part trying to get that down in there. Hmm. Yep, I just broke the part. Okay, so I'm going to need to reprint a couple of pieces here. Not a worry. Um, they're a quick print. These were done in the uh, ah, doesn't matter. It was done in the dark magic. So let me just pull up my bamboo slicer and I will get those ready to go. It'll take just a couple of minutes to print. Of course, there's a new configuration package. Why wouldn't there be? Okay, so we need ant head, user mods, standard flow nozzle LEDs. Okay, I'm going to do this. Okay, sorry about that. I was just trying to get that print set up. Now, what I'm doing, because I broke this, I'm increasing this to 100.5%, and I'm taking this down to 99.5%. So there'll be a slight difference in the sizing. That should give me the ability to get in there without busting things up. Um, Now, what we'll do is we'll see what else we can do to keep getting prepped and ready. So we want to get the lower ones in first, but we can look at getting this in place. And we'll go ahead and slide this into the slot, or work on sliding this into the slot. Yeah, that's fully slotted in. I'm going to take my wires and bring them around into our groove. Just kind of work those down in there so that it'll sit flat when we go to install this on the printer itself. So there we go. Once again, these wires are going to go into that end piece. It'll slide on here. We'll need to add in our front grill here. We should be able to do that without much fanfare. Should be able to do that without much fanfare. And actually, nope, we should be good. It's another one of those, this is going to be a tight fit. And there is a groove that fits in, so you just have to kind of work down into that groove. Kind of like before, where it pops up fully seated, just like that, if you've got it in the right spot. So that part's done, and we're ready to rock. It may take a little pressure to press it into place. Just be careful not to break the edges of it. You may have to lightly sand the edges to get it to go in. I probably could have taken a file right to the edge a little bit. We can't install this part just yet because we need to get the lower lights in place. So once that print's done, we can get that installed, and we'll be using M3x6 button head cap screws. And I don't remember, was there M3x6 even in here? I don't think there was. There was not, but that's okay because I do have M3x6, so we can get that covered. Then we need to delid our 4010 fans, and this is what I wanted to kind of work on here while we're waiting, is our other fans here, right? So we need to delid the blower fans. And I have never delidded these. Doesn't look like it'd be hard. It looks like it just pries off. Or just pull up on them and it comes off. Insert the 4010 fan into the fan duct with the open duct heading down to the lower port here. And depending on which one you're doing, will tell you where your wire needs to go. In this case, the wire. So we've got the blower fan coming down towards our duct. This is going to slide in. Haha, yes. It should slide in. Might have to do a tiny flex on the part. There we go. Tiny little flex just to get it started. Slide it in. Being careful that you don't catch on your fan. You got to make sure that you're going in evenly. There we go. Get it in place. Make sure that it's pushed all the way in. And at this point, it is now, I will say, locked because it is rubbing up against this piece. Now, they are not using, what are they? I don't know what kind of fans they're using. Yeah, they want you to fasten the fan. If I fasten the fan, it's going to push the fan into the face of the printed part. I may have to relieve this printed part some. Hey, Petty. I mean, it's definitely a tight fit on here, but you can see where it's going to catch the top edge up here. And I've pulled it way out, but if I even make it just flush, you'll see that this now no longer moves. Or it moves, but it's dragging across the front face of the printed part here. So I'm going to have to relieve these printed parts, or potentially just reprint these and raise them up to like 101%. Let me do a quick deburr operation and see if that relieves anything. And it could be the print orientation on these as well. These printed with this edge on the bed. So they printed like this. Okay. I'm wondering if they really needed to be printed like this orientation. I don't know, because that's some obtuse angles there. Yeah, it's this front edge here has to be brought way out. And it could also be the fans, right? We're using 4010 blower fans from Honey Badger. Not saying it's a Honey Badger issue, but just fans are slightly different sometimes. So you have to be able to account for that. Um, and I just don't think I'm going to be able to open this up enough with just a file. Yeah, rotary goes through. That is true. We could use a rotary tool on it. You know, we're just working the opening with our half round file. Okay, that has fixed it. We're spinning fine. So we should be good. Looks like we just needed to give it a little love. Means we'll probably need to do that on the other side as well. Um, so how let me see. I'm gonna mount like this. So this is already going to the back. There is a cable spot right there. Might have to do some wire routing. All I'm doing is just flexing and pulling up a little bit, and these clips are coming right out. So as you can see, there's just little slits cut in there that it press fits into. So a little flex and that pops right off. We'll see if this one will need some adjustment as well. So in this case, the fan blower is going this way, and this wire routing, I think, is going to wind up going up and around the front. Yeah, angle grinder. I mean, I wouldn't have used an angle grinder. I would have used the Dremel. But yeah, you can use sandpaper. You can use a file. Anything just to relieve that edge a little bit. Once again, we've got a slightly raised edge. We're just going to try and get rid of that. Now let's drive this back in here and dry fit it, see if it works out for us. Still dragging a bit. I mean, it's moving easier, but it is still dragging. So we'll need to work on the edges a little bit more. The burning tool is going to hopefully clear up some of that edge. But yeah, I hope everybody's having a good day today, having a good week. It's almost the weekend. Hez is supposed to be giving us a countdown. She's slacking and not doing it. But I think we're somewhere under 40 days, or 40, yes, 40 something days out of 3D Printopia. If you do not have your hotel yet, you might want to get on that. I mentioned it to KB3D and they were like, oh yeah, we should probably get on that. I'm like, yeah, maybe. Maybe. I say that as I was trying to figure out what hotel they were staying at so I could try and get close. Probably for the cough too. I'm still dealing with some allergy stuff, so. Yeah. And this one's going to require a bit more work. Now, on this one, it's not the front edge, it's this rear edge that's the problem. So I'm going to try and blend this down some more. And like I said, the other thing I can really do is look at printing these at like 101% because I feel like with the fans that it's causing it to kind of bow like that, which is forcing this edge down and into the fan blades. Right. We'll see. We'll do a little bit of refinement work here. Open the hole up some. This would probably be a good place, like if I had better CAD skills, to just go ahead and modify this. But the Dragon's CAD skills are not that good. You could probably muddle through to a degree, but oh, we're almost there. So we just need to relieve this edge a little bit more and we'll be there. Hey, AD Creations, how's it going? Welcome in. Hey, Maker Viking. Or SB Creations. I'm sorry, that's Silverback. Hey, Silverback, how's it going? Wick Allen, welcome in. Sorry I missed you earlier. And Pez is back. Imagine that. Pez coming back with a raid. We are providing some slight persuasive modifications to these parts. Once again, it could literally just be the fact that we're using Honey Badger fans, and this part may have been designed around like GD Stein or Pick brand, and that's why we're having this fitment issue with the fan blades. Don't sit here and think, oh my gosh, these parts suck. Nope. It really could simply be the fan that we're using from manufacturer A versus manufacturer B. Okay, now this should be, I think, final test fit. So close. Not final test fit. One more. There probably are fan ducts designed for the honey badger. I don't know where to find them. I did not see them in the user mods. I will double check, but I don't think there are clicky duct. Yeah, I don't see them for the honey badgers unless they are listed under the honey badger stuff. Hey, Jedi Spidey, how are you today? Hope you're doing good, my friend. We are modifying the shape of our duct to clear the spinny bits of our fan. So slight modification of the duct, clearing the spinny bits. And we have good clearance on spinning bits now. Spinning bits are spinning without any hits or noise. We had to do that on both of our fans, but we got there in the end. I do want to relieve this one ever so slightly, a little bit more. It's kind of close. Oh, what are you making noises for? Did I get a filament break or did it just fully loosen out? Ah, I know what happened. The filament came loose from the spool, so the spool's freewheeling and the filament's not moving anywhere. Okay, so this one goes chill. Spinny bits do the spinny bit thing. Hey, awesome. So we need to add a couple of screws on here. Let me clean off my file real fast. Okay. So where are we at? M2x6 button head screws, which are those are socket heads. M2x6 button heads. I don't have button heads, but I should be good to go with the socket heads because which ones are we doing? We're doing these two here. We're going to be putting screws right into these two edges here, and there should be enough of a relief for them to go down on there. Wires feed through. Checking fitment and stuff right now. Looks like we're good there, so give me my wire back. So M2x6, and then I'll take a look again and see if I really do need button heads. If I need button heads, that's going to suck. I'm not sure if I have button heads at 2x6. These are going to be screwing into plastic. I really, really hope that these clear. I mean, they should be good because they're right at the same level of the fan itself. So that should clear just fine. Let's do another fitment test. And yeah, that's going to work just fine. That's going to work just fine. So that one's done. We'll put two over on this side. And once again, we're small, tiny screw, very tiny threads, and we're threading into plastic. So no ugga-duggas. HB92 ducks, eh? So I may have to print feeling under the weather, but I think you'll survive. Okay. Well, I hope you do feel better there, Jedi Spidey. How goes all the sanding? So let's take a look. You said man ant head, STLs, ducks, the standard flow. Ah, and you're right. There is HB92. I didn't realize what the HB was. Gotcha. Well, isn't that awesome? So I'll go ahead and put those off stream. I'm pretty sure those were not the ones that I did. Pretty sure. But I can go ahead and get those ready to rock and roll right now. Ant head, STL, ducks, standard flow. That one. That one. All right, and I'll get those prepped and ready to go. Easy enough to swap out. So where are we at on temperature wise right here? Still at 70. I can't pull stuff off the plate at 70. And I say that because I've yelled at people for doing it. So yes, this is well. We've got I believe the high flow 60-watt heater, but it is a Revo, right? So thanks for the lurk, Liz. Supper time, gotcha. It was addressed in issue number 6 on GitHub. Well, thank you, Wickallen. I obviously did not dig deep enough. Thank you. I will tell you that The plan for this is an EBB 36 board versus, doing like a Nighthawk. And I dread these with a passion. I hate these little tiny screw down terminals. And I've got several EBB 36s. This is the bane of my existence. But we're going to be installing this onto the back of our extruder. Our extruder, that's the long one. So we'll throw that away so I stop grabbing it. So I need to get heat sets on this. That was a tool. I think this is also a tool, so we don't need that. I need to put heat sets on this piece, and it will be our standoff on the other side of our extruder. So here's our extruder. This is the low side. This is the high side. We're going to mount this board on the high side, or this piece like this. And this is going to allow us to mount the piezo board for the piezo sensor on this. So I'm going to need to put some heat sets in there. For small ones like that, you just tin the heater wires. For small ones like what? What did I miss there, Wick Allen? Oh, on the tool board. Yeah, I really have a dislike for tinning wires going into crimp connectors like that, especially um, heater wires. Um, but yeah, I get what you're saying. Like our printed part currently comes with our printed part. The tool head wire currently comes with ferrules, but they're the white ones, and they're going to be too big. So yeah, we're going to wind up having to do something to those wires to make them as small as possible to get them in there. And maybe that is what we wind up doing overall. Now, I'm also debating on whether or not I need to add, get the next size larger, because there's about like, I don't know, 2.5, maybe 3 threads exposed there. Maybe 3 exposed threads. So not a lot of meat there. There's a part of me that, to say, I wonder if I could just open this up and make it a press fit like sleeve for one of these to go all the way through it. But then the issue is, can this board then rotate around a lot? I do think what I really need to do though is go the next longer screw here. Yeah, strip the wire back, tin it, use heat shrink. Yep. I think this is a 35, so we'd have to go to a 40. That's 35. Pretty sure I don't have like a 36, so I'd have to go to a 40. Socket head. Yep, have to go to a 40. I have a socket head, not a button head. The question on this one is, will it be too long now? Yeah, so that'll be there. And once again, we'll have the little piezo board that will mount right here. We'll have the one wire that comes up into the piezo board from the tool head, and then the cable will come out of here and go into our EBB 36 board at the back, which will mount. Let's see, this is going to go there and there. And actually be too long. I may have to go down to, might have to go down to an M3 by 6 or, yeah, M3 by 6. Nope, we're good. So there's our pull board mount in the back. The things are coming together. We're at least making some progress while we're working and waiting and letting things cool off. You're done enough. Yeah, and I do know, I built the Micron to the R1 beta spec a while ago. It's just been a while. So And all the files have changed. A lot of files have changed. I did not build it with an ant head. I'm trying to remember what I did use on it, but it wasn't an ant head. And so far, I'm kind of liking the ant head. I mean, there's plenty of options for it. Few nuts and a death will. It'll be any size you want. Yep, that is true, Otter's Danger Den. That is true. That is very true. So you'll see that we have a 2-wire popping out here. This is for the filament sensor. So there is a filament sensor at the top, and there is, I'll say, a dead one at the bottom. So we did rebuild this using the latest stuff. There's a filament sensor at the top, which is a ball bearing and a D2F end stop. Same thing underneath. This one is just not wired up to anything. It is literally there because, well, this file only had the 2. So I'm going to use the top one, not implement the bottom one, because we're not putting the leaf cutter on here. We're not doing filament cutting. This is going to give him a filament runout sensor above the extruder gear. So that way he can pretty much run it all the way to the end and not have, like a, let me go all the way around and outside the printer type of filament sensor setup. Okay, so we were going to look at getting the lights mounted into here. And we should be good to try again now. This goes in there. Hopefully we can work with these and not have to worry about trying to pop the light back out. And we're going to pop our light back out. If hopefully I can get it back out. Because I think the issue that I'm having is with the actual straight bars that I used, which is not a bad thing. It's just I need to tweak them some. They needs to be tweaked a bit because of the printed part. That's the only reason, is the printed part. So we'll get the hot thing over here. Ah. It has. Like it's always worked pretty good for me. Um we get I'll figure out how the best way to do this is going to be. Definitely not that. Kind of what I need to do is move the 5-volt and ground in a little bit to give me a tad bit more room in the printed part. Not that far. All right, so I have sufficiently just screwed that up. Yep, we just sufficiently screwed that up. By we, I mean I did. What are we making? We're making a mess, apparently. We are making a mess. I was trying to fix some LED wiring and I have made it worse and cross-bridged a bunch of stuff. And I may just have to cut my losses and desolder the one side and grab 2 new ones. Because I don't know if I'm going to get those apart again. All right, Omnifixo. Omnifixo. Solder. Because my tip needs some solder to conduct heat a little bit better than it is. Let's clean the tip. Okay. All right, so we may have just saved ourselves. We'll need another pen, but I may have just saved it. So let me see if I can get my main eyeballs out here, make sure I'm not cross bridging. Am down at that end. So was not the anticipated plan. But now we've got things undone, so we should be able to come back in here and redo this. We'll have two of our pieces as they need to be. We'll just need to reflow the solder to them. Okay. Now we're kind of back at the beginning, and I'm going to need to pull one more pin. What we're using is just a JST pin from one of our connectors. I've got the type of connectors that you can solder in, and all we did was just grab one of these and pull it out. Probably be using the pliers and not the snips. And this gets considerably easier if you apply a little bit of heat to the pin. But just like that, we just pulled a pin out. And we're going to use that pin to lay it across and do the jumpers. So the issue that I had was that I had it on the outer edge, and I really need it more on like the inner edge of the solder joint. So, dang it. Wires, work with me, dang it. We'll tin the edges of our pin here. And I just did it again. Damn it. All right, I'm done. I'm going to do this off screen because if I continue to try and do it on screen, I'm going to get frustrated, and don't don't do soldering when you're frustrated. It's never going to turn out well, and I just soldered all three of these pins together. So, and I'll be surprised if I didn't cook that LED in the process. I'll see if I can't clean everything off again, and I'll start fresh. But for now, folks, I am going to say thanks for being here. Thanks for hanging out with me. It's 9 o'clock. It's a little bit, we've been going for close to 3 hours, and I can feel my frustration level rising a little bit doing this soldering. This is the one thing that kind of drives me nuts, is soldering LEDs, just because it's so tiny. But we'll get there. We'll get there. We'll get this done. It is Thursday night, which should be marble races with Big Jano. Though I saw Jano on last night. Nope, he's up. Good. Is he just getting started? Oh, yeah, he's on like a 7-minute countdown. So let's chat for a little bit. What I'll do is I'll try and clear the pads off of the one side real fast. And that way I'll be ready to start the solder process again. But yeah, we're going to give Jano just a short little bit, and we'll try and catch his stream tonight. We love hanging out with Jano. He does all kinds of cool projects. He's normally doing LED projects. So maybe I can get some tips watching him on how to do my LEDs and not screw things up as badly as I just did. But yeah, it's kind of where we're at. We'll just say it'll be a good day. Tomorrow's Friday. Yay! Then it's the weekend. Yay! We will be streaming on Saturdays, so there's no event going on. So that'll be nice. Yeah, what else? I don't think there's anything else really going on. We'll set that in there. We'll set this one in there, and we'll try and get this done again. Yep. Hopefully everybody has a great night and a good weekend. And yeah, I'm just trying to give Jano another minute or so. So while we wait, I did talk a little bit at the beginning of the stream about, affiliate links. So we've got several new affiliate links that have been added out there. Amame. We've also got Voxel PLA. So if you have bamboos, they've got the drop-in replacements that are HEPA filter and charcoal. where the typical bamboo one is just a HEPA filter, which means it collects particles, but it doesn't do anything for the smell of your engineering materials. So those are great drop-in replacements. I just went and ordered a few of them myself today. We've got Vision Miner, so if you need a bed adhesive, I will say Vision Miner works very well. And, well, I just ordered some voxel PLA filament. I did order some actual PLA. They have PLA and they have PETG. I did order some PLA to check that out and test it out. I know like ModBot uses it a lot, and he seems to have really good luck with it. So I really like EPACs as well because they're local to me. But yes, I am looking for options to bring to bear. So we're going to give that a shot. Hey, Vampire Toothy, welcome in. Thank you for the follow. We are chit-chatting for just a couple of minutes. We're on a countdown. We're going to raid over into Big Jano because I am in the process of trying to solder some LEDs, and I can feel my frustration level getting up there. So I'm going to stop while the stopping's good, and I'll go relax, and I'll tackle this problem again tomorrow. And worst case scenario, we just go to the single logo LED and call it good. Yeah, I think the new prints will help out. Like I said, I did the carrier at 101% and the little clip that holds it in place at 99, so, or 99.5. So I have about a 1% tolerance difference in the parts now, and I'm going to hopefully see if that gives me the little bit extra that I needed to not snap the part when I put this in. That's going to be the hope. I'm not sure if there's a trick. I will watch how Steve Builds did his and got his installed, because I know he broke his on his first try as well. Thin parts and tight tolerances are no fun, especially on small items. And maybe I'll try and go with wire this second time around instead of trying to do the pins. It might just be easier to do it that way, and potentially could give me a little bit of leeway in those parts as well. But all right, folks, I think we're good now. I'm going to go ahead and get the raid started. Once again, thank you all for being here for the Micron build. We got the gantry or the AB belts installed. We got the tool head X carriage installed. We've got the hot end installed, and we're working on the shroud and everything that goes around it. And progress is progress. So thank you all for being here. No ad. Thank you all for being here, and I will see you guys Saturday morning, bright and early, 10 a.m. Eastern time, and we'll get started. You use diode legs. I didn't even think about that. I do have plenty of diodes in there. I can cut them because they're going to be thinner as well than the pins. I didn't even think about that. Thanks for that suggestion, Wick Allen. I appreciate that. You guys have a great night, and let's go have fun with Jano, do some marble races later on tonight. So thank you all for being here. Have a great night. We'll see you later. Bye now. And for those of you that are watching this later on YouTube, thank you for sticking around. Sorry, I know I get a little frustrated sometimes doing these builds. Thank you for being here, sticking around. If you like what you see, please be sure to hit the like button. Show me that you guys like the content. Please leave a comment as well. Be sure to subscribe, click the bell, be notified of future videos. Speaking of future videos, YouTube's going to be suggesting one right over here.